So this is the paper 2 2025 advance, right? So let x naught be the real number such that it satisfies this equation. For given real number alpha, gx is this. For all real number x, which one is true? Right. So for this we can write g of x is, right, here you can take 3x common, right. So 3x common, e power x plus 1 minus alpha common, e power x plus x, right. Here divide by 3 e power x plus 1, again here also 3 into e power x plus 1, okay, 3 cancel, e power x plus 1 cancel. So we have g of x is equal to x here minus alpha by 3 times e power x plus x by e power x plus 1, right. This is g of x. Now I will add both sides g of x plus e power x naught, because in this every question e power x naught is there. That is why add both sides g of x plus e power x naught. That is, e power x naught is what? Minus x naught. So here minus x naught minus alpha by 3 e power x plus x by e power x plus 1. Okay, both sides e power x naught added, because according to question, right. Now see, if you take in this x naught, this 0, e power x naught 0, this value is 0, right. So at this x naught, if you put, what is this value? 0, right, because x naught minus x naught 0, e power x naught plus x naught is 0 given. So this part is 0. So now we can write, right. So limit x tends to x naught, x tends to x naught, right. I am finding alpha value, right. Instead of searching every option, I am finding alpha value, right. That is modulus of g of x plus e power x naught by x minus x naught. See, this is a 0 by 0 form, because this is 0, right, at x naught. So 0 by 0 form. So I will do that L'Hospital rule inside. So what is that? Limit x tends to x naught g dash x, right, this is constant, by 1. So it is nothing but what? G dash x naught, g dash x naught, okay, 1. But g of x is this, no? We can find g dash x and put x equal to x naught. What happened? We'll see. So that is right, g dash x I will find out, right, g dash x. So g dash x equal to, here x derivative to 1, right, and alpha by 3 into u by v method. So alpha by 3 minus alpha by 3 and e power x plus 1 and e power x plus 1 minus e power x plus x into e power x whole by e power x plus 1 whole square, right. Okay, now in this I will put what is that? X naught. So g dash x naught is equal to 1 minus alpha by 3. This is a e power x naught plus 1 whole square minus e power x naught plus x naught into e power x naught whole by e power x naught plus 1 whole square. But e power x naught plus x naught 0 given. So this part is 0, this cancel 1. So therefore here g dash x naught is equal to 1 minus alpha by 3 into 1, because this cancels, this is 0, right. E power x naught plus x naught is what? 0. This portion is 0. This portion is 0. So, therefore, here 1. So, but this is, if it is 0, alpha by 3 is equal to 1, alpha is 3. So, therefore, right. So, this is if mod of g dash x naught is equal to 0, therefore, 1 minus alpha by 3 is 0, so alpha is 3. So, therefore, if alpha 3, this limit is 0, alpha 3 limit 0 means C, right, alpha 3 this is 0, but it is 2 by 3, option D. So, therefore, C is correct. Now, here, what is that? R denotes the real number, the area of the region bounded by this and this 3. So, for this, we will consider equal sign to draw the curves. Okay. So, consider y is equal to 1 by x, equation 1, 5x minus 4y, right, minus 1, 0, equation 2. Here inequalities are there, that I am considering equal to, because to draw the graphs, right, and 4x plus 4y, right, is equal to 17, equation number 3. So, this is a rectangle hyperbola, positive only, x greater than 0, right. That means these are two straight lines. So, therefore, the curve is like this. Okay. So, therefore, you can take, right. So, this is a what? Rectangular hyperbola. Of course, x positive, this side only, first quadrant only, right. And this is what second equation, y0, x 1 by 5, x0, y minus. So, it is what? Negative, matlab like this it is, right. Okay. Now, another is 17 like this. Yes, this is the, now which area greater than 0, for this less than 0, this above greater than 0. So, this portion, right. So, therefore, area of this we want, okay, that is the required area, right. So, if you draw perpendiculars like this, draw perpendiculars, okay. So, we will get this is what? This is A, B, C, D, E, F, okay, right. So, if you put y is equal to 1 by x, matlab solve 1 and 2, right. So, solve 1 and 2, put y equal to 1 by x in 2, So, what is that? 5x minus 4 by x minus 1, 0. So, 5x square minus x minus 4, 0. So, x is equal to 1. So, x is equal to 1. This is 1. Okay. So, x is 1. X is 1, so y is 1. Y is 1. Right. Because trapezium. Now, solve this 2 and 3. Solve 2 and 3. So, solve 2 and 3, add 2 plus 3. 2 plus 3. What is that? 9x is equal to 18. X is equal to 2. You know, 9x equal to 18, x is 2. X is 2. So, x2 to we will get y, right, x2. This is equal to what? 8. 17 minus 8, 9. 9 by 4. So, this is 2 comma, this is 2, this is 9 by 4 length, CD length. Now, y equal to 1 by x and what is the third equation? Put, you write y equal to 9 by 4. What is that next? You solve 1 and 3. Put y equal to 1 by x in the third equation. So, put y equal to 1 by x in third. What you will get? 4x plus 4 by x is equal to 17, that is 4x square minus 17x plus 4. So 4 4 16, x is equal to 4. है ना? 4 comma 1 by 4. So don't take this. Here 1 by 4 we don't. So x equal to 4 you take. है ना? 16, 78. So x is 4, this is 4. X is 4, y is 1 by 4 this. Okay. Now required area is what? This trapezium plus this trapezium minus 1 to 4 rectangle hyperbola. So therefore required area is equal to area of trapezium A, B, C, D, right? Area of trapezium A, B, C, D plus area of trapezium C, D, E, F, right? C, D, E, F, area of trapezium C, D, E, F minus integral 1 to 4 rectangle hyperbola minus integral 1 to 4 1 by x dx. Yes, this is. Therefore, required area. What is the area of rectangle trapezium of h into a plus b? H is 1, a 1, b 9 by 4. Of h is 1, a plus b 1 plus 9 by 4 plus same of h into a plus h is what? 2, 4 minus 2, 2 distance between parallel lines. So that is half 2 into 9 by 4 plus 1 by 4. This is a log x, right? 1 to 4, right? So what is this? This is a 13 by 8, 2 to cancel, plus 10 by 4 minus log 4, that is log 4. So this is what 33, here multiply by 2, 20 by 8, 20 plus 13, 33 by 8 minus log 4. So this is what B option correct, right? Now this is what number of solutions of the equation, right? Number of solutions of the equation. So now first we will take this is alpha. You take this is alpha, say, right? Now what happened? This we will take this is the equation 1, right? So what is our alpha? Alpha is right? Alpha is equal to 1 by 2, right? From 1 by 2 onwards, not minus, right? Sin inverse of 6 tan theta whole by 9 plus tan square theta. 9 plus tan squared. So 2 alpha is equal to sin inverse of 6 tan theta by 9 plus tan square theta, right? Now this sin 2 alpha is equal to 6 tan theta by 9 plus tan square theta. Okay. Now sin 2 alpha, you know, 2 tan alpha by 1 plus tan square alpha. So you write this as in terms of tan. So 2 tan alpha by 1 plus tan square alpha, that is equal to 6 tan theta by 9 plus tan square theta. Okay, 2 3s are cut. Right, now simplify, cross multiply. So what is that? You will get 3 tan theta plus 3 tan theta tan square alpha is equal to 9 tan alpha plus tan square theta tan alpha. Yes, cross multiply. Now transfer this side, everything to this side. So what you will get, this is 3 tan theta plus 3 tan square 3 tan theta tan square alpha minus 9 tan alpha minus tan square theta tan alpha is equal to 0, right? Now in this first, third, 3 common. First, third term, 3 common. So 3 tan theta minus 3 tan alpha, and second, fourth, minus tan theta tan alpha common. Minus tan theta tan alpha common. Here you will get tan theta minus here 3 tan alpha. 3 tan alpha is equal to 0, right? Minus tan theta common, tan theta tan alpha common, so minus 3 tan alpha. Now again tan theta minus 3 tan alpha common. So tan theta minus 3 tan alpha into 3 minus tan theta tan alpha is equal to 0. So we want values of theta, not alpha. Alpha just we introduced. So therefore from this, what is tan alpha is equal to tan theta by 3. Now this is what tan alpha is equal to 3 by tan theta. 2 cases, right? Now what is the equation? 1 becomes theta plus alpha is equal to this, right? Therefore, but 1 implies theta is equal to tan inverse of 2 tan theta minus alpha, right? Alpha turns this side. So theta plus alpha is tan inverse. Here all this is what including this only, principal range only. So no need of what thinking this, right? So pi minus, pi plus, minus pi plus, no. So only because principal solution, that is why you can write it like this. So 2 tan theta and tan trans this side. So tan of theta plus alpha is equal to 2 tan theta. Now it is tan A plus B, you know tan A plus B, that is equal to, you can write, right? So therefore tan theta plus tan alpha whole by 1 minus tan theta tan alpha is equal to, what is that? 2 tan theta. Okay, now first we will take tan alpha is tan theta by 3, substitute here. So therefore tan theta plus tan theta by 3, tan theta whole by 3, 1 minus tan square theta by 3 is equal to 2 tan theta. This is 3 plus 1, 4 tan theta, 4 tan theta by 3 cancel, 3 minus tan square theta minus 2 tan theta 0. Okay, 2 tan theta common. 2 tan theta common in the bracket 2 by 3 minus tan square theta minus 1 0, right? Because 2 tan theta common here 1 only. So tan theta 0, and here 2 minus 3 plus tan square theta 0. So tan square theta is 1. Tan theta plus minus 1, right? Therefore theta is pi by 4 minus pi by 4, not 135, because minus pi plus pi 2 only. So minus pi by 4, and theta is here 0. So therefore here 3 solutions, right? 3 solutions. Now second case we will do. Second case is there now. tan alpha is 3 by tan theta. We will substitute in this. So, tan theta plus tan alpha is 3 by tan theta. 3 by tan theta by 1 minus 3. Because cancel, tan theta cancel 3. So, is equal to 2 tan theta, right. So, what will get this? Tan square theta plus 3 by minus 2 tan theta, because 1 minus 3 minus tan LCM is equal to 2 tan theta, cross multiply. So, tan square theta plus 3 minus 2 tan square theta. So, that is 3 plus, sorry, this is 4, right, 2 square, 4 plus 1, 5 tan square, imaginary. So, tan theta imaginary, no solution, right, imaginary, right. So, therefore, no solution. So, ultimately, what is that? 3 solutions only. So, therefore, 3 solutions. So, that is C correct. What is this? Let us denote the locus of point of intersection of pair of lines. This where alpha varies, right, T is a tangent to S passing through the points P0, 0, Q, Q positive parallel to the line this, then the value of PQ is, okay. So, therefore, here can take the first equation, okay, right. This equation will write 4x plus 3y equal to 12 by alpha, right. If you multiply 1 and 2, you will get alpha cancel, you will get the locus, which is a what? Hyperbola. So, 1 into 2 multiplying. So, a plus b minus b. So, 16x square minus 9y square is equal to 12 into 12, 144. Okay. Alpha cancel, right. So, divide by 16, x square by 9, y square by 16 is equal to 1. This is what? S, right. So, which is a hyperbola. So, now for this T is a tangent to this S passing through these points where Q positive parallel to this line passing through origin, right. Okay. So, right. So, this is the figure, this is the hyperbola, right. This is the hyperbola, right. This line is this. So, this line passing through origin, right. Now, there is a tangent, T is a tangent, right, T is a tangent parallel to this. So, something like this we can take. So, it is a tangent T, okay, because P positive, no. So, that is why I drawn like this, okay. So, this is a 0 comma Q, this is 0 comma Q. So, it is 0 comma minus, this is P comma 0. Now, I think P must be negative, right, okay. So, these two parallel, okay. Now, we can write slope of this is what? 4 root 2 by 3, that is slope of tangent, right. Slope of given line, 4x minus 3y by root 2 equal to 0 is 4 root 2 by 3. So, this is the slope of tangent, right. This is M, right. Therefore, any tangent to the hyperbola, is, right, any tangent to the hyperbola is, what is that? Y is equal to mx, m is 4 root 2 by 3 mx plus minus root of, right, root of a square m square minus b square. A square is how much? 9. A square m square is this. 16 into 2 by 9 minus b square is 16. Cancel. So, y is equal to 4 root 2x plus minus 32 minus 16, 4. Oh, this is 3, not x, huh? Right, numerator x, this is 3. Okay, now what is that? Q positive will take plus. So, as Q positive implies, so 3y is equal to 4 root 2x plus 12. Because Q positive, that is why you take plus, right? If you take minus, then Q will be negative. How to find these intercepts? Put x0, right? Put x0, you will get y. So, what is that y? Y is 4. Y is 4. This is nothing but Q. Now, put y0. Put y0, x will be minus 12 by 4, minus 3 by root 2. So, x is minus 3 by root 2, which is q. Therefore, PQ, P is what? 4 minus 3 by root 2. This is equal to, this is what we can write, minus 12 by root 2. This is minus 6 into 2 by root 2. So, root 2 times cancel, minus 6 root 2. This is answer. So, option A. So, what is this here? Matrix, right? I given, P given, Q for some non-zero real numbers x, y, z, for which there is a 2 by 2 matrix R with entries non-zero real numbers such that QR is equal to RP. Then which of the following statements is or true? So, it is more than one type, right? Okay. So, here what is given? QR is equal to RP, right? Okay, I will write here QR is equal to RP, right? See, in the options 2i, 6i, 3i is there. Okay, with that I am subtracting 2r both sides. QR minus 2r is equal to RP minus 2r, like this. Okay, here you can take r common from right side, q minus 2i into r. Now, here r common, p minus 2i, p minus 2i. Okay, what is p minus 2i? You can calculate. This is p minus 2i, right? So, q minus 2i into r is equal to r times. So, this matrix is p minus 2i, 0, 0, 3 minus 1. So, 0, 0, 1, 2 minus 2. Okay, so p minus 2i matrix. This minus this 2, this multiplied by 2. 2 minus 2, 0, 0, 0, 3 minus 2, 1. So, 0, 0, 1, this is 0, 0, 1, yes, okay, this is P minus 2i matrix, okay. So, now we will take determinant both sides, right, okay. So, determinant of Q minus 2i into determinant of R is equal to determinant of R into this determinant is 0. Determinant of 0, 0, 0, 1, determinant is 0. So, therefore, q minus 2i, right, is equal to 0, right. So, q minus 2i determinant is 0, that is A correct, right. Now, q minus 2i is 0 will give what? So, q minus 2i determinant of, right, q minus 2i, q is how much? Q is this. So, x, y, z 4 minus 2i 2, 0, 0, 2, right, is equal to 0, right. So, what is this? Determinant of x minus 2, y, z minus 0, 4 minus 2 is 2 is equal to 0. So, what is this? 2 times x minus 2 minus yz 0. Okay, this is the equation. So, this is 2 times x minus 2 is equal to yz, equation 1, right. Now, here 3i, 6i also there. So, we will subtract 3r, right, subtract 3r. So, from that what you will get, we will see, okay. Okay, this is or now we can do that, right. I am subtracting this instead of 2r, 3r, right. So, what is that? QR is equal to RP given, subtract 3R is equal to RP minus 3R. Okay, R common from post, this into R common P minus 3I. Yes. Now again P minus 3I we can calculate. P minus 3I. Okay. So, Q minus 3I into R is equal to R times, right. So, P matrix is what? 2 0 0 3 minus 3 0 0 3. Yes. Okay. So, what is this? Q minus 3I times R is equal to R times, what is this matrix? Minus 1 0 0 0. Yes. So, now we will take what both sides determinant. So, determinant of Q minus 3I, right, into determinant of R is equal to determinant of R into this again 0, determinant of this 0, right. So, therefore, determinant of Q minus 3I is 0, right. Okay. Determinant of R, we will not tell anything here. So, that is why determinant of Q3I is 0. But determinant of Q3I is Q minus 3I 15 given. Right. Now, we can check BD. Right. It is more than 1. So, this implies what? What will guess? Determinant of Q minus 3I. Q is XYZ4, XYZ4 minus 3I, 3003, right, is equal to 0. So, determinant of x minus 3, y, z minus 0, z, 4 minus 3, 1 is equal to 0. So, it is what? X minus 3 minus yz 0. So, x minus 3 is equal to yz, equation number 2. So, from 1 and 2 we will get x value, right. So, therefore, from 1 and 2, right, from 1 and 2, right, from 1 and 2, right, equate these two, 2 times x minus 2 is equal to x minus 3. So, 2x minus 4, x minus 3, so x is equal to 1. X equal to 1, so yz is minus 2, implies yz is minus 2. So, therefore, D wrong. Now, we have to find out determinant of Q minus 6i, right. Okay, Q minus 6i. So, determinant of, right, determinant of Q minus 6i. So, what is that? Determinant of Q minus 6i is equal to, so determinant of Q is XYZ4 minus 6i, 6006, right. So, what is this? Determinant of x minus 6, y, z minus 2. This is what? Minus 2 times x minus 6 minus yz. Now, minus 2 into x is 1, 1 minus 6 and yz is minus 2 plus 2. So, this is what? 10. 10 plus 2, 12. So, 12, right? Yes, B correct, right? A, B correct. Now, this is what? Here, let S be the denote the locus of midpoints of those chords of the parabola y square equal to x such that area of the region enclosed between the parabola and the chord is 4 by 3. Let R denote the region lying in the first quadrant enclosed by parabola y square x, the curve S, and the lines x equal to x over 4. Then which of the following is are true? Okay, right. So, what is that? Let S denote the locus of midpoints of chords of parabola such that area of region enclosed between the parabola and chord is 4 by 3. Okay. So, before this, area of the region bounded by area bounded by y square, y is equal to x equal to anyone, no problem, x equal to ay square plus by plus c and x equal to my plus c is delta power 3 by 2 by 6a square. What is delta? Delta is the discriminant of the quadratic equation, this, where delta is discriminant, right, of the quadratic equation. You solve this. Now both are equal, no? Ay square plus by plus c. Okay, this you can take k here. So is equal to my plus k. Yes, this quadratic equation. So this I am applying. Now here, what is that? So this is the parabola y square equal to x parabola, like this. Now this midpoint locus. So you take h comma k locus, midpoint locus, right? This locus. This is a midpoint. Now, so this area is 4 by 3. Okay, this area is 4 by 3, right? So therefore, we can find equation of the chord. T is equal to S1. So equation of the chord with midpoint right, is T is equal to S1, right. What is our T? Now parabola is y square, so y1, yk, right, minus 1 by 2 x plus h is equal to S1. Substitute the point in this. So k square minus h. So now from here 2ky minus x minus h, 2k square minus 2h. So 2ky minus x, right, minus 2k square and plus h is equal to 0. So from this, what is x value? X is equal to 2ky minus 2k square plus h. Right. Now area bounded by y square equal this and x equal this. So use delta power 3 by 2 by 6a square. So what is that? Here this parabola, this you solve. Put this in the y square equal to x. You will get quadratic in y. For that discriminant power 3 by 2 by 6a square, we will get the locus of hk. So therefore, what is that? Right. So therefore, this put in y square is equal to x. So, you will get, therefore, y square is equal to x is this 2ky minus 2k square plus h. So, y square minus 2ky plus 2k square minus h 0. So, area is 4 by 3 given, this area. This area is given what? 4 by 3 square units. Now, that area we can find by using this result, delta power 3 by 2 by 6a square. So, what is that here? So, delta power 3 by 2 by 6a square is 4 by 3 given. Okay, now we will find out delta b square 4k square minus 4ac 8k square plus 4h power 3 by 2 by 6 into 1 y square coefficient is equal to 4 by 3. Of course, 3 2s are, right. So, what is this? This is 4h minus 4k square. 4h minus 4k square. 4h minus 4k square. 4h minus 4k square. 4h minus 4k square power 3 by 2 is equal to 8. Is equal to 8. Cross multiply, right? Here 4 common 8 because power 3 by 2 is there. H minus k square power 3 by 2 is 8. So, therefore, 8 cancel. Therefore, locus of h comma k. Locus of h comma k is x minus k square, x minus y square. X minus y square is equal to 1. So, it is y square is equal to x minus 1. This is again parabola. So, this yes, if you put this in this, this is s, this is s. Substitute here 3 was satisfied, right? Put 4 comma root 3, yes. So, this is what 3 is equal to 3, satisfied. So, A correct, right? A correct. So, now you can take what is that 5 root 2, no, this is not satisfying. This is 2 is equal to 4, this is not. Now, we have to find area. So, area bounded by what? The parabola and S and 1, 2, 4. Matlab like this. See, this is a, okay, this is the again figure. So, this figure is like this. So, this is the y square equal to x parabola. Now, and this parabola, S parabola, vertex is 1, 0, like this. Okay, x equal to 1 means this is x equal to 1 line, x equal to 4 line. So, this area, okay. So, this area we can take here. Yes, this area we have to find. So, it is a simple case. You can take, right? Oh, this is okay. So, right. So, 1 to 4. This is 1. This is 4. Right? Required area 1 to 4 upper parabola minus lower parabola. So, therefore, required area integral 1 to 4 root x minus root x minus 1. This you integrate, you will get this 4 by 14 by 3 to root 3. Okay? 14 by 3 minus 2 root 3 you will get. Right? So, this is what x power 3 by 2 into 2 by 3 minus x minus 1 power 3 by 2 into 2 by 3, 1 to 4. So, 2 by 3 out, substitute upper limit 4 power 3 by 2, 8, 4 minus 1, 3 root 3, minus 1, minus 1, minus 0. So, this is what, right, 16 by 3 minus 2, this is what, 1 minute, we can first simplify inside portion, 2 by 3, 8 minus 1, 7 minus 3 root 3. So, this is what 14 by 3 minus 2 root 3. Yes, this is the answer. Yes, C correct. C. So, this is what ellipse problem. P x1, y1, Q x2, y2 are distinct points on the ellipse, and y1, y2 positive, y1, y2 positive, right, and C denotes the circle. This is what auxiliary circle, right? M be the point 30. Suppose the line x equal to x1 intersects C at R, and line x equal to x2 intersects C at S, such that y coordinate of R, S are positive. Let ROM pi by 6, pi by 3. O denotes the origin. XY is the distance between x and y point. Then which of the following are correct? Okay. So, for this, okay, I will move up because space is not there, right. So, it is A greater than B ellipse, right. A greater than B ellipse, we can draw A greater than B, and it is the auxiliary circle, right. Now, we can find the equation of PQ and these distances, right. For this, what we can take, okay, here only we can take, right. Right. So, this is the A greater than B. First you write the circle, right. First you draw the circle, and here center, then ellipse. Yes. So, this is the figure. This is a x-axis, right. Y-axis, y-axis. So, this is the 0, 0 center, right. This is the C curve, x square plus y square 9 is the auxiliary circle, and points on the ellipse, right, ellipse, okay, right. So, this is what 30 M30 here, M30, that is the positive end of major axis, and Px1, y1 is a point here, right, Px1, y1, and right, the line, what is that? Okay, x1, y1 and M the point, okay. Now, suppose the line x equal to x1 intersects C at R. This is C, right. This is the, like this is the Px1, y1, and this C at R, okay. Now, next, x equal to x2 intersect C at S, such that y coordinates are positive, PO ROM pi by 6, SOM this, okay. So, we can take here another like this. This is the Q point x2, y2. This is S, okay. Now, ROM, right, ROM is, this is ROM, this is 30 degrees, SOM is 60 degrees, so this is 30, right, that is OR is angle bisector, okay. Now, it is the point N1 x1 0, this is N1 x1 0, right, this is N2 x2 0, yes, this is the figure. So, it is nothing but based on what, eccentric angle, okay. This is 30 means this point is A cos theta, B sin theta, okay. Now, we can write the points, eccentric angle. This is theta means a cos theta, b sin theta this. This point is a cos theta, a sin theta, like that. So, therefore, P x1 y1 we can write P x1 y1, right. P x1 y1 is, what is that? A cos theta. A is how much? 3, right now? A 3, B 2, okay. So, A cos theta, A is what? 3, cos theta cos 30, and B sin 30, 2 sin 30, right. A cos theta, B sin theta, okay. So, this is a P x1 y1 is equal to 3 root 3 by 2 comma 1. This is a P coordinates. We can find R coordinates also, right. R coordinates also required, yes, N1 R na, right. R coordinate corresponding point on the auxiliary circle, A cos theta, A sin theta, and right, and R coordinates A cos theta. A is what? 3, cos 30, and A sin 30, A sin 30, yes. So, R is 3 root 3 by 2 comma 3 by 2 sin 30, okay. Now, in the same way, Q point is 60 degrees eccentric angle point, 60 degrees. So, therefore, we can write Q point, right, Qx1 y1, Qx1 y1, what is that? A cos 60, because total 60, 30, 30. So, A is 3 cos 60 and B 2 sin 60. So, therefore, this is 3 by 2 sin 60 root 3 by 2 root 3. This is the Q point. Now, S point corresponding point on the circle. So, therefore, S point is A cos 60, 3 cos 60, A sin 60, 3 sin 60. So, therefore, S is 3 by 2 comma 3 root 3 by 2. Now, we can find everything in this. Now, the equation of line joining P and Q is this, right, P and Q, right, 2x plus 0 this, okay. Now, we can find equation of PQ, right. So, you know P point and you know Q point, we can find equation of PQ, or you know P eccentric angle, Q eccentric angle, then chord joining alpha beta, right. So, what is that? That way I am doing, right. So, if you take alpha is 60 degrees, beta is 30 degrees, therefore, equation of PQ is x by a cos alpha plus beta by 2, y by b sin alpha plus beta by 2, right, is equal to cos alpha minus beta by 2. This is the equation of the chord joining alpha beta on the ellipse. Now, alpha beta substitute, a substitute. So, x by 3 cos 45, right, y by b 2 sin 45, right, is equal to cos 30 by 2 15 degrees. So, this 1 by root 2, x by 3 root 2 plus y by 2 root 2 cos 15 root 3 plus 1 by 2 root 2. So, root 2 cut, LCM 6, 2x plus 3y, 2 cut, 3 into root 3 plus 1. So, what is that? 2x plus 3. So, this is A correct, right. So, B wrong, because same question, right. Now, what is that here? What is that? We want a question, N2 is this, then 3N2Q and 2N2S. So, N2Q by N2S, N2Q by N2S, that is nothing but B by A, correct. So, therefore, we can take, right. So, therefore, I am doing this n2q by n2s, n2q by n2s. So, n2q by n2s, n2s, okay. So, n2q is this distance, q is this now, q is this. So, root 3, n2q is root 3, root 3 by n2s, this y coordinate, s y coordinate 3 root 3 by 2, 3 root 3 by 2. So, cancel 2 by 3. So, cross multiply 2 n2s, 2 n2s equal 3 n2q, 3 n2q, yes. So, what is that? It is there now, 3 n2q is equal 2 n2s, yes, correct. So, that is option C correct, right? Option C correct. So, this A correct and C correct. What about this? What is this? Question is N1P, N1R. Okay, same way, N1P, N1R. Okay, now we can find, right, N1P by N1R. Okay, N1P means this y coordinate, Py coordinate. Py coordinate is 1. Py coordinate is 1 by N1R, Ry coordinate. Ry coordinate 3 by 2. 3 by 2. So, it is nothing but 2 by 3. So, 2 times N1R is equal to 3 times N1P. So, this is wrong because 9 is given, right? This is a wrong. So, these two correct. Okay. Now, see here, this is a, let R denote a set of all real numbers, R to R be given like this. So, it is obviously continuous, because 0 by 0 if you apply L'Hospital rule. So, limit is equal to this, because 6 plus 1, 7 by 3, right, continuous function this. Now, we can find, what is that? So, the point x equal to 0 is the point of local maxima. This number of local maxima in my interval, yes. So, we can find, so f dash x, because it is a continuous, right, we will find out f dash x. So, what is that f dash x? This is a, we can find f dash x, right, we can find here, okay, can find, okay, put here, right, we can find, right. So, we can find f dash x. So, f dash x equal to, this is what u by v will apply. So, 2x plus sin x, 2x plus sin x into 6 plus cos x minus 6x plus sin x and 2 plus cos x, 2 plus cos x whole by, that is 2x plus sin x whole square, 2x plus sin x whole square, right. Now, we will simplify u by v, this into this derivative plus this derivative, right. So, what we will get this f dash x equal to 12x plus 2x cos x and 6 sin x plus sin x cos x, sin x cos x minus 12x minus 6x cos x minus 2 sin x minus sin x cos x whole by 2x plus sin x whole square, right. Okay, now here 12x cancel, sin cos, sin x cos x cancel. So, what you will get, you have f dash x equal to 2x cos this, 6 minus 2, 4 sin x 4 sin x minus 4x cos x whole by 2x plus sin x whole square, right? Okay, you can take, of course, this x not equal to 0, x not equal to 0 given, right? X not equal to 0, okay. Now, so what is this from here? You can take 4 cos x common, right? F dash x is 4 cos x common, tan x minus x you will get, you know, here sin by cos, and by, what is that? So 2x plus sin x whole square, right? X not equal to 0, right? Here 4 cos x common, sin by cos tan minus x, right? Now x not equal to 0, therefore we can, this is positive, this is cos positive in the neighborhood. Okay, now we will take this tan x and x, right? So if you draw tan x and x graph, what you will get this. So therefore, right, so this is minus pi by 2, 0, so therefore this is a tan graph, right, like this, and this is a pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, and so on, right. So therefore this is this is at 0, at pi again cuts like this, at 2 pi it cuts, right. Now if you take this as can take, so here this is 3 pi, 7 pi by 2, okay. So what is this? Where it 2 pi, 3 pi it cuts, yes. So like this, here it is passing to this, so origin like this, this is. So obviously at 0 neighborhood, 0 plus positive, 0 minus negative, so that means it is what? Local minima. So therefore, right now, what we can write? So therefore, here f dash 0 plus is positive and f dash 0 minus is negative. Therefore, what is that? Sign changes, what? Positive to negative. This is what? Local minima, right? Local minima, what is that given? But it is given local maxima, so it is not correct. So, but B is correct, local minima, right? Local minima. Oh, this is not going, okay. So B correct. So number of local maxima in the interval 0 pi to 6 pi is 3. Yes. See here, from this, here there is a, right, one point, another point, like another point. So there are 3. So therefore, B correct, right, C correct. Then number of points, right, number of points in the interval 2 pi to 4 pi, local minima 1, right. So local minima 1. So therefore D also right from the figure. Okay. So B, C, D correct. So now it is what? let y of x be the solution of differential equation, this x greater than 1 by e, and satisfying y of 1 0 the value of this. Now it is what? A homogeneous differential equation, right? So what is this? So dy by dx, right, is equal to x square plus y square minus xy by x square. So x square plus y square minus xy by x square. So this is homogeneous differential equation. Homogeneous differential equation of degree 2. So put y equal to vx, y equal to vx, right? Therefore dy by dx is equal to v plus x dv by dx. So put 2 3 in 1. Put 2 3 in 1, right? Put 2 3 in 1. So therefore v plus x dv by dx, right, is equal to 1 plus v square minus v, because x square cancel. So v transfers that side, x dv by dx 1 v square minus 2v plus 1. So v minus 1 whole square. So variables separables we can. So dv by v minus 1 whole square is equal to dx by x. Integrate, right? This is what? Minus 1 by v minus 1 is equal to log x plus c, right? Log x plus c. So, but this multiply by 1 by 1 minus v y by x is equal to log x plus c, right? So, x goes up, x by x minus y is equal to log x plus c, equation number 4. Now put 1 0, x1 y0, put, right, 1 comma 0. So x is 1, y 0. So 1 by 1 is equal to 0 plus. So c is 1. C is 1. Put in 4. Put in 4, right? So what is this? X by x minus y is equal to log x plus 1, right? So therefore this is what? X minus y by x is equal to 1 by 1 plus log x, right? X by x 1 minus y by x is equal to 1 by 1 plus log x, right? So y by x is equal to 1 minus 1 by 1 plus log x, right? LCM. So y by x is 1 plus log x minus 1 by 1 plus log x. So 1 cancel, x cross multiply, x log x by 1 plus log x. This is the function. He is asking what? 2y is. So therefore 2, this is a 2y of e square by y of e square. So y of e is what? E log e 1 by 1 plus log e 1 square by y e square. So e square log e square 2 by 1 plus 2. 1 plus 2. So what is this value? 2 times e square by 4 into 3 by 2 e square. 2 e square cut 3 by 4. So 0.75. 0.75. Now this is a, what is that? A0, A2, 3 be real numbers such that this is a for every real number x, right? For every real number x, AR be the largest among the numbers AI for this. Then the value of R is. So it is nothing but what? Numerically greatest term. So what is that? So here 1 plus 2x by 5 power 23. So numerically greatest term, right? Numerical greatest term, that is what? N plus 1 by 1 plus, this is 5 by 2x. So mod 5 by 2x. So in this put n is 23, x is 1. So put n is equal to 23 and x is equal to 1, right? So what happened is, therefore n plus 1 by 1 plus 5 by 2x is equal to n plus 1 24 by 1 plus 5 by 2. This is what? 48 by 7. So it is what? 6 plus 2 by 7. This is what? 6 plus f. F is 0 to 1. Right. So therefore, seventh term is numerically greatest term. Right. Seventh term is numerically greatest term. Therefore, R is 6. Therefore, T7, no? T7, that is T6 plus 1. So therefore, R is 6. Therefore, A6 is large. A6 is largest. Okay. Right. So R is 6. So what is this question based on? Probability. A factory has a total of 3 manufacturing units M1, M2, M3 which produce bulbs right, independent each other. The units M1, M2, M3 produce bulbs in the proportions 2 to 1 respectively. It is known that 20% of the bulbs produced in the factory are defective. It is also known that of all the bulbs produced by M1, 15% is defective. Suppose that if a randomly chosen bulb produced in the factory is found to be defective, so probability that it was produced by M2 is 2 by 5. If a bulb is right, chosen randomly from the bulbs produced by M3, probability of that is defective is okay. So now we will introduce some events, right? What is that? So you can take, let H1 right be the event, bulb right is produced by unit M1. Now similarly H2 is by what is that? M2. H3 is by unit M3. Okay, and E, let E is the event that bulb is defective. Right? Yes. Now, according to the condition is what? The probabilities of the M1, M2, M3 is in the ratio 2 to 1. That means P of H1 is 2 by 5. 2 plus 1, 4, that is P of, therefore P of H1 is 2 by 5. And P of H2 also 2 by 5. And P of H3 is 1 by 5. P of H3 is 1 by 5. Okay. Now, next 20% of bulbs produce defective. That is defective is this. So, P of E is 20 by 100. 20 by 100. That is what? 1 by 5. And 15% are defective by M1. Hello, probability of E by H1. Right? Probability of E by H1 is given that what? 15%. 15 by 100. that is 5 3s are 5 20s. And next, what is that? The probability that it was produced by M2 is 2 by 5 defective. That means probability of H2 by E, right? Probability of H2 by E is given how much? 2 by 5. Yes, he is asking what this probability of by M3, right? It is chosen bulb is produced by M3, that is E by H3. E by H3 we want. Okay. So now by using total probability theorem, P of E we can write, right? So therefore from total probability theorem, therefore P of E we can write now. What is that? P of E? P of H1 into P of E by H1. Yes. Plus P of H2, P of E by H2, and P of H3 and P of E by H3. Yes. P of E by H3. Right, P of E by H3, right? Now substitute in this, we don't know E by H2, E by H3, but he is asking E by H3, okay? Now what is this? You can, P of E how much? P of E 1 by 5, substitute here. So 1 by 5, P of H1 2 by 5, P of E by H1, 3 by 20, P of H2 2 by 5, this we don't know, P of E by H2 we don't know, P of this 1 by 5 into P of H by E3, this also we don't know, okay. Now you can simplify this, right? So 5 cancel now, 5 cancel 1. So 1 minus here 3 by 10 is equal to 2 times probability of E by H2 plus probability of, this E by not H by. So E by H3, okay. Now it is what? 7 by 10 this is, therefore 2 times probability of E by H2, probability of E by H3 is equal to 7 by 10, equation 1, right? But what is asking? Bulb is chosen random from the bulb produced by M3. E by H3 we want, probability of E by H3 we want, right? So for this, one more condition is given, probability of H2 by E given, 2 by 5, right? If it is E by H2 is known, we can find E by H3, that we can use this equation. So P of, right, but probability of H2 by E, this is what? 2 by 5. This is what? By conditional probability H2 intersection E by P of E, right? This is a definition of conditional probability. Then from this product theorem, P of H2 into P of E by H2, product theorem, is equal to 2 by 5 into P of E. And P of H2 2 by 5, yes. P of E by H2 we don't know. And 2 by 5 into P of E 1 by 5, we can substitute here, 1 by 5. So 1 by 5 cancel, 2 cancel. So P of E by H2 is 1 by 5. This is 2. Put 2 in 1, we will get P of H by 3, that we will get this. So put in 1. So put in 1 right? So 2 times P of this P of E by H2 1 by 5 plus P of E by H3, this only we want, is equal to 7 by 10. So P of E by H3 is equal to 7 by 10 minus 2 by 5. 2 by 5. That means multiply divided by 2. 7 minus 4 by 10. 7 minus 4, 3 by 10. P of E by H3 is, what is that? 7 by 10 minus 4 by 10. So 3 by 10. That is what? 0.30. This is answer. So now this is the question, right? Consider the vectors this and for two distinct positive real numbers alpha beta, capital X, capital Y, so they will coplanar, then alpha plus beta minus 3. So therefore coplanar means box product 0, right? So therefore X bar, Y bar, capital Y, capital Z are coplanar because they lie in the same plane. Therefore box product XYZ 0, right? So XYZ, so X is this, right? Here X bar, Y bar, Z bar is there. So therefore coefficients, determinant alpha beta minus 1, right? Alpha beta minus 1. Here alpha X bar is minus 1, X bar, Y bar, Z bar coefficient order we had, right? Minus 1, alpha, Z is beta. Now here X is beta, Y minus 1 and Z is alpha into X bar, Y bar, Z bar. This is a property, right? Okay, into here X bar, Y bar, Z bar, that. But X bar, Y bar, Z bar box is this 1, 2, 3, 2, 3, 1, that is. Okay, so therefore here I think this is a non-coplanar. This 1, 2, 3, 2, 3, 1, they are non-coplanar. So therefore you can transfer that side. So therefore simply this is 0, right? So therefore this is not 0, right? Okay, non-coplanar vectors. So therefore determinant of alpha beta minus 1, right? Alpha beta minus 1, here minus 1 alpha y alpha and Z is beta. Yes. Next X beta minus 1 alpha, correct? Beta minus 1 alpha 0. Yes. Now expand this determinant. So what is this? Alpha into alpha square plus beta, right? Minus beta times minus alpha minus beta square, minus alpha minus beta square, minus 1 into 1 minus alpha beta 0, right? So alpha cube, alpha beta, beta cube minus 1 plus alpha beta 0, right? So alpha cube, beta cube and minus 1 is equal to minus 3 alpha beta, right? Now it is like a cube plus b cube plus c cube is equal to 3abc, c minus 1. So a plus is 0. So therefore alpha plus beta minus 1 0. So we want minus 3, subtract 2. Alpha plus beta minus 3 is minus 2. So therefore answer is minus 2. Now here this is what is that? This is what the principal argument range. Omega is cube root of unity, then let alpha is this, then the value of 3 alpha by pi. Okay, now we can write this expansion, summation. So what is that? Alpha is equal to argument of, right? You expand n is equal to 1 to 20 to 25 minus omega power 1 plus minus omega power 2 minus omega power 3 and so on minus omega power 2025, right. This is GP with the 2025 terms. So, therefore, alpha is argument of, right, minus omega, that is GP sum A into R power n minus 1 by R minus 1, that formula I am using. Common ratio also minus omega power 2025 by this is minus omega minus 1, this is, right. So, this minus, okay, right, this minus cancel, because 2025 order, minus cancel, outside minus omega is there. So, argument of minus omega, this is omega cube power 675, that is 1, okay, by 1 plus omega. So, this is numerator 2 minus 2 omega square, right. So, alpha is equal to argument of minus omega 1 plus 1 by 1 plus omega, right. So, argument of minus omega, this is 2 minus omega square, okay, cancel. So, 1 omega cancel. So, argument of 2 into 1 you can write omega cube by omega, right. So, omega cancel omega square. So, argument of 2 omega square, you know omega square value minus 1 minus I root 3 by 2 to cut. Therefore, alpha is argument of, what is that, minus 1 minus I root 3. This is what, third quadrant, minus pi plus tan inverse y by x. So, minus pi plus tan inverse of modulus of minus root 3 by minus 1, So, that is what, minus pi plus, this is pi by 3, 60 degrees. So, alpha is minus 2 pi by 3. So, is asking 3 alpha by pi. So, minus 2. So, minus 2.00. That is 3 alpha by pi asking. So, what is this here? So, f is given, g is given, right. Define the composite function like this, okay. G inverse is the inverse of the function g, then the value of derivative of this composite function f circle g inverse at x equal to, okay. So, now here we can find g inverse easily here, right. So, g inverse we can find. Otherwise, we can find this g of fx is 1 if g inverse is not able to find, but you can find g inverse easily here, right. So, therefore, here what is that, g of x is equal to 4 by 1 plus e power minus 2x. This you take y, right, y. So, therefore, 4 by 1 plus e power minus 2x. So, e power minus 2x, 4 by y, 1 transfer that side, e power minus 2x, 4 by y minus 1, 4 by y. Now, take logarithms, minus 2x is log 4 minus y by y, okay, x equal to minus 1 by 2 log 4 minus y by y, yes. So, we will take minus cancel, we will reverse it, right. So, therefore, x is equal to, what is that, 1 by 2 log y by 4 minus y. This is what g inverse y, this is g inverse y. So, 1 by 2 log, right, 4, y by 4 minus y, then change y to x, we will get G inverse x. So, G inverse x equal to, what is that? 1 by 2 log x by 4 minus x. Okay, you call it as hx, say hx, this is hx. Okay, you call it as hx, right? Right, now what is the h of 2? That is G inverse of 2. G inverse of 2 is 0 because 1 by 2 log 1, 2 by 2 na, log 1, that is h of 2. Therefore, h of 2 is 0. Right. Now he is asking what? Derivative of f inverse G circle x. Now we can find what is this? Derivative of this f. So, now what is that? F circle G inverse of x, right? That is nothing but f of G inverse x. Okay, but G inverse x is what? Hx. So, that is equal to f of hx. Hx. Now, we want fx, you know, then wherever x you write this, right? So, what is that? This is nothing but log of hx square plus 2hx plus 4. This. We want derivative of this at x is 2, right? Okay, you take this is y, right? Now, dy by dx, right? So, derivative of this is what? Hx whole square plus 2hx plus 4 into derivative of this 2hx into h dash x. 2hx into h dash x plus 2h dash x. So, h dash x out, right? But hx is this, no? We can find h dash x also. So, therefore, dy by dx is equal to 2hx plus 2 whole by hx whole square 2h of x plus 4, okay, into derivative of h dash x, means derivative of this, okay, that is 1 by 2 log x divided 1 by x minus log 4 minus x divided to 1 by 4 minus x into minus 1. In this, put x is equal to 2. So, you will get what is that? See, this is equal to h of 2 0, 0 plus 2 by 0, 0, 4, this is denominator, into 1 by 2, 1 by 2, here plus 1 by 2, okay, this is 1, 2 to cancel, okay, 2 by 4 into 1 by 2 into 1. So, 2 to cancel 1 by 4, that is 0.25, this is the answer, this is a 0.25. Now, here this is a right question, trigonometric question, right? This models we discussed in the class also, right, last year. See, 60, 61, 62, 60, all consecutive numbers, right? So, we can write this is alpha is equal to, right, 1 by sin 60, 61, right, 61, this is alpha, okay, multiply by sin 1 degree both sides, okay, here. Now, this is what sin 1 degree, here also sin 1 degree, because that 1 degree we can write 61 minus 60, that is the idea. So, then we can sin a minus b divide, okay. Now, here what is that? 62, 63, sin 1 degree by 62, 63, 62, 63 plus and so on. What is last but one? Sin 1 degree by 16, 17, sin 116, sin 117. plus last one is sine 1 degree by 18, 19. 18, 19. Okay. Now we will write numerator 1 degree, sine 1 degree we can write like this. So alpha into sine 1 degree is equal to sine 61 minus 60 we can write by sine 60 into sine 61 plus this is 63 minus 62 at right, this sine 1 degree. So 63 minus 62 degrees right by sine 62 63 degrees plus so on. This is a sine 117 minus 116 whole by sine 116 into sine 117, right, sine 117. Now plus sine 119 minus 118 by sine 118 sine 119. Okay. Now we can write it as alpha into sine 1 degree is equal to sine A cos B minus cos sine B and divide. Sine A means this 61 cancel. So cos by sine is cot 60 minus cot 61. Like this you will get. Okay. Now plus here 60 61 no, small number first, then next. This is a 62 63, right? This is what? 62 63. Next 64 65. 64 65 like this and so on. Last, what is that? We'll get last, right? Last is here. This is 116 minus 117, right? 116 minus 117 plus 118 119 119. Yes, these are the numbers. See here telescopic terms not cancel, but from back side we can cancel it. How? This sine can be written as, so this cot, sorry, this is all cot, right? This is what cot, right? Cot 116, cot 11, cot 11, cot 118. Now we can write this as, right, is asking this, okay. So we can take, right, can put here, can write here this alpha into sine 1 degree. This is a cot 60 minus cos 61, cot 62 63 and so on. Now here last is this cot 118, cot 118 what we can write now? Cot 118 you can write 180 minus 62, 118. So but minus cot 62 this is. So this is minus cot 62 and this minus plus cot 61. So backside will cancel all. Backside cancel. So we have this like this here, this cancel. So you will get only cot 60 will remaining. Alpha into sine 1 degree, alpha into sine 1 degree is equal to cot 60. Yes, this is remaining. Okay. So therefore alpha into sine 1 degree is equal to cot 60 1 by root 3. So cross multiply this 1 by alpha into sine 1 degree. Sine 1 goes numerator cosecant. So root 3 is cosecant 1 degree by alpha, square both sides. So this is cosecant 1 degree by alpha square. So 3 is the answer. Now last question. So the same model question we are given in the our practice questions, right? 16th exam, May 16th we conducted one practice test. In that question is like same like 0 to infinity tan inverse x by, right, this something like quadratic, same quadratic function. So this way, right, is equal to a by b, then ask 1 plus a minus b step. This is the question, right? Same model, right? So this is also like that only. Now you can put here equation 1. This is, so this is the equation 1, right? We will put x equal to 1 by t. Put x equal to 1 by t. So dx is minus 1 by t square dt, right? So therefore alpha becomes what? Here 1 by 2 becomes 2, 2 becomes 1 by 2. Tan inverse of 1 by t, right? Now 2 by t square, and minus 3 by t plus 2 minus 1 by t square dt, right? Now tan inverse 1 by t is what? Cot inverse t, because principal range say less only, initial principal range. So that is equal to, here minus this interchange, limits cancel. So 1 by 2 to 2, cot inverse t change as x, there x square x cancel, same 2x square minus 3x plus 2 dx, right? 2, change t to x, dummy variable, add 1 and 2. So 1 plus 2 implies 2 alpha is equal to 1 by 2 to 2 tan inverse x plus cot inverse x pi by 2 by, this is a 2x square minus 3x plus 2. This is a simple integration by 1 by quadratic. So alpha is pi by 4, right? So alpha is equal to pi by 4, right? Pi by 4, 1 by 2 to 2 dx by, what is that? 2x square minus 3x plus 2. Okay. So this is what is asking, what 4 alpha tan. We put alpha here only, right? This is equal to 1 by 2, 2. This is what 8 dx by derivative 4x minus 3 whole square. Discriminant is what? 9 minus 16 minus 7. So plus root 7 square. So I make it perfect square. 1 by x square plus a square. 1 by a times x by a. So therefore 4 alpha by pi is equal to 8 times 1 by a, 1 by root 7 tan inverse x by a, 4x minus 3 by root 7, and divide by x coefficient 4, 1 by 2 to 2, right? So that is what, this is 2 times, this is a 2 times, here also 2 times cancel, 2 root 7 alpha by pi, right, is equal to, this is what, tan inverse of, if you take upper limit 8 minus 3, 5 by root 7 minus tan inverse, this is 2 minus 3 minus 1 by root 7, but principal value minus 5, so it is plus. So 2 root 7 alpha by pi is tan inverse 5 by root 7 plus tan inverse 1 by root 7. This is like tan inverse x plus tan inverse y. So 2 root 7 alpha by pi, that is tan inverse of 5 by root 7 plus 1 by root 7 by 1 minus 5 by 7. Now transfer this side. Tan of 2 root 7 alpha by pi is equal to 6 by root 7, and here 7 minus 7 upon 2. So 2 3s are. So root 7 times, you transfer this root 7, you will get root 7 tan of 2 root 7 alpha by pi is equal to 21. Yes, this is answer.